Good morning, respected sir and all participants. Myself, Shamal Salunkhe, research scholar of Electrical Engineering Department of VJTI. I'm working as an assistant professor in IIT Navi Mumbai. I'm presenting here our research work, nature-inspired algorithm for pixel location optimization in video steganography using deep RNN. The digital revolution brings security-based problems. The digital steganography is used for secure communication. This is overview of the seminar, introduction, literature survey, proposed algorithm, comparative analysis, conclusion, futures scope, and some of the selected references. Steganography is a technique used to hide secret messages into the multimedia signals such as text, audio, image, and video. In video steganography, secret information is hidden inside the video. It provides secure communication with good impersonality. Three approaches of video steganography. First one is still image-based steganography. Here, firstly, video is splitted into the frames, then selected or keyframes are used to hide the secret data. The proposed work is based on this approach. Second one is format-based steganography. It is designed for particular video format, like compressed or non-compressed video format. Approach take advantage of 3D nature of video, some additional features such as motion then motion vectors. Literature review, I have selected
Shamal, we cannot hear from you anymore.
I'm sorry, because of network problem, I got.
Okay, you have some more minutes. I don't know what.
Yeah, sir. Yes. This
is
go
ahead for a couple of minutes if you can go.
This is literature review. The proposed WEWO algorithm is employed for training of deep RNN. The proposed WEWO algorithm tunes optimal weights for pixel prediction. The deep RNN identify the exact location where secret message can be embedded. We have checked for robustness by adding paper and salt and pepper noise in the keyframes. This is our proposed algorithm. First step is initialization. Here we have taken one keyframe that is mentioned by Z, and Z1 up to ZK. These are number of pixels. These are nothing but our various solutions. Step number 2, determination of fitness value of every pixel. The optimal pixel is find out based on mean square error criteria. Here R stands for keyframe, S stands for secret frame, M and N are scalar vectors. It gives fitness of every pixel. Then third step is based on determination of weights. As we are using meta-heuristic algorithm, it is combination of water wave algorithm along with earthworm algorithm, and we have picked up reproduction or crossover function from earthworm algorithm and crossover function from water wave algorithm, and we combine them, club them together to get better result and to minimize the problem of local minima. Step number 4 is error or update solution. whatever the fitness value is stored, and then based on that these values, deep RNN has been trained. Step number 5 is termination
Shamal, 2
criteria,
minutes.
where maximum. Yes.
You have 2 minutes
Hello?
more.
Yes, sir. Yes, sir. Thank you, sir. Maximum iteration criteria has been applied over here for termination. CAVIAR is my data set. This is a video data set where various activities has been recorded in terms of short video clips. Correlation coefficient, it gives us idea about similarity factor between two frames. First one is key frame and second one is embedded frame. PSNR is a secondary similarity giving factor, which gives us idea how embedding has been performed nicely. These are my results. I have picked up 2 videos from this data set, video 1 and video 2, and impulse noise or paper and salt noise and paper noise add up over here. We can see over here as noise get increased, then correlation coefficient and PSNR goes on decreasing. This is for second video. This is for second video. This is comparative analysis, and I have compared total 3 methods with my proposed WEWO algorithm. First one is DWT DCT. This is the embedding criteria. DWT is again embedding criteria, and DCNN is training deep learning model. Same is LSB DCNN. LSB is embedding and DCNN is my deep learning method. And this is my proposed algorithm. We observe better results over here. Conclusion, the proposed WEWO algorithm is employed for tuning of optimal weights, and it gives better result, like PSNR is reached up to 43.87 decibel, and correlation coefficient is 0.97 over here. And my next plan, my future work will be utilization of motion vectors or to exploit 3D nature of videos. That's all from my side. I have given here selected references. Thank you.